Okay, good afternoon, everyone. So now we're going to see the living planet. One of the things about Earth science at NASA is that we use the same engineers and the same project managers to build satellites that have instruments on them, which instead of looking away from the Earth, so within NASA, we have the same engineers and project managers who build satellites for space science and Earth science. And the difference is our space science friends look away from the Earth, and our Earth science people like myself use the satellites to look down at the Earth. So what we see is the Earth day after day, orbit after orbit, month after month, year after year, decade after decade. And this is a visualization of data from CWIFs, from the MODIS Aqua instrument, and also from the NOAA-NASA VEERS instrument on NPP. And what these different colors show are the density of chlorophyll on the planet, in the oceans and on land at the same time step. Then you'll also notice now it's summer, and here comes winter, and so the snow comes down. So it shows what a dynamic Earth we have. If you only have one glimpse at some place, you really don't know very much about it. With Earth science and with satellite data, we're able to have an unprecedented understanding of the Earth through time, as it varies, and where it doesn't vary. Now, it's really interesting if you look in the oceans where you have these deep blue colors. These are biological deserts in the ocean. There's no chlorophyll there, and that's because there are no nutrients. If you look at other areas which are close to the coast, you have these various red colors, which are the highest density of chlorophyll, and then then those grade into the yellow colors. So this is why close to all of the continental margins, you have a lot of very productive fisheries. And that's because you have a lot of phytoplankton there. Now, if you look on land, it's really neat because you can see the variation in the growing season. And you'll notice that it moves north and then it moves south in Africa with time. And that's because the intertropical convergence zone moves north and south, driven by the position of the sun and surface temperature. Now you'll notice it's winter, and shortly we'll see that as the snows recede, now we have the pulse of photosynthesis and chlorophyll at higher northern latitudes. Now it's winter again. Here we go back. So when we have data over 20 years in this systematic time step by month after month over 20 years for the oceans and land, these are actually quantitative data which can be used for a wide range of scientific studies. And they are fundamental to understanding the carbon cycle on land, because photosynthesis takes carbon dioxide out of the atmosphere, and this results in phytoplankton blooms in the oceans, which are the basis for the food webs in the oceans. And on land, it's the basis for vegetation which we see, and the differences between winter and summer, which we observe ourselves. Now, some very interesting things is you can use these data for food security. If you want to study the production in agricultural areas, time series quantitative data like these are fundamental to studying the production of crops for crop growing areas. At the end of this simulation, I will show two examples of. But in the meantime, what I like to do is just watch this as it oscillates around, because these are the actual growing conditions as measured from satellites of life on the planet, in the oceans and on land. Now you'll notice when we come to some areas, you'll see a very dramatic greening in Australia because of a El Nino event in 2010, which resulted in the deposition of a huge volume of water upon Australia. And then it turns Australia green, and this was a very marked event in 2010 and 2011. The sea surface elevation data showed a drop in the mean sea level at that time, and people wondered what the heck is going on, because sea level is the best indicator of whether the Earth is warming or cooling. Then along came gravity data from the GRACE satellite duo, and they showed this huge accumulation of mass from water in the interior of Australia. In the meantime, the climate change deniers were saying, look, all of your sea level rise data are a bunch of malarkey. But then it was explained, no, that water fell in the interior of Australia. And so then everything was reconciled. So in Earth science at NASA, we use satellite data to study a wide range of geophysical variables and people should disregard geophysical variables and what they mean at their own risk. But this is the basis for visualizations like this. Is this about at the end? Okay, should we just go to... Yeah. Okay, so now we'll jump to some examples of how I and my coworkers use these data to study food security. So the relationship we use is this comparison between the time integral of chlorophyll fluorescence, a measure of gross primary production, and an index which we measure from a NASA satellite called MODIS on two platforms, on the Terra platform and on the Aqua platform. And you'll notice they are extremely highly correlated, and that's because both are measuring gross primary production or photosynthesis on land. So then we're able to take these data. The chlorophyll fluorescence data are measured at a scale of 40 by 80 kilometers, but the MODIS data are measured at the scale of 250 meters. So we're then able to extrapolate this measure of gross photosynthesis down to 250 meters. So we have used these data to study agricultural production with our coworkers from the Department of Agriculture's Foreign Agricultural Service. Because we know fairly well what's happening in the U.S., but many times we have no idea what's happening outside of the U.S. And so this is an example on the top panel from Turkey, from this area. Here we have, from our Air Force colleagues, we have excellent precipitation data. And then this is the area we're looking at. And this is the profile of data as they were through June of 2017. And you'll notice this red line, and this is the profile of average conditions, maximum and also minimum. And the black line is the median of those values. And you'll notice things are lagging like this, and then suddenly they improve. Here's the area again. Then we see a few weeks later that things have dramatically improved, and now they're on the high side. So if anyone based an inference upon this image, they would be mistaken. You have to follow these processes through time. So when you do, it then came down like this, and it resulted in a record yield of wheat in Turkey. So this is one use of these data outside of the U.S. is to study foreign agricultural production. Here is another example from South Africa for their corn crop. This is the area in question. It was very dry in 2015, and then in 2016 it was much wetter. Here are the crop profiles. So we're up like this on the high side of the time series data from 2000 through 2016 and 17 of the min and the max. And then it continues on. Here's the final figure right here, and what it shows is an indication of a record yield for corn in South Africa. Now, all of this information is published every month by our Department of Agriculture, and the current report came out on Tuesday of this week. These are freely available, but that's one use of quantitative satellite data, and that is to study agricultural production outside of the U.S. in a quantitative way. Now, I also and my colleagues use these data to study the carbon cycle and how much carbon is incorporated in vegetation and how photosynthesis on the planet is progressing, but that's too difficult to explain in just a few minutes. So I picked an easy example of food security. And now I'd like to make the transition to a tribute to one of our departed colleagues, Pierre Sellers. Pierre Sellers came to the Goddard Space Flight Center in 1982. I was fortunate to work very closely with him, as were many people. Then he left to become an astronaut. He flew in space on STS-112, 121, and 132. And after the space shuttle program ended, he then came back to the Goddard Space Flight Center as the head of Earth Science. He passed away, unfortunately, just about a year ago, but he was an inspiration to many of us. I don't think he had any enemies, even though there were 2 or 3 people who didn't like him. There were very few, but he was a humanist. He had a phenomenal sense of humor, and he inspired many of us here to work really hard, and he thought we were all in this together. And even though we're facing serious environmental problems, he was convinced that we can solve them together. So let it roll.
We're very fortunate working in the field that we do. It's incredibly fascinating and exacting and interesting. You know, most of my friends are at work. Every day I work with my friends. I love it.
The anesthetic process interacts with the atmosphere.
Computers are looking out for food.
Our astronauts are making their way to the Astra van that will take them out to the launch pad.
Atlanta 6 go.
Another great remote sensing defense sensors operate all my station. I'll come to your office and I'll not let you relax. No, it was good. It was good.
What you guys are doing for your second career?
I think we'll be unemployed.
The first couple of days are a bit, disorienting. It all straightens out. You become like a little, I don't know, some sort of flying squirrel. You can bounce around inside the space station from wall to wall. It's just charming.
This is easy. I'm just like a torpedo going down the middle of the service module. I love it.
Guys, I gotta tell you, I think my spatula escaped. That feed on me.
Well, the spatula was a bad moment because it was my favorite spatula. Looking at the Earth from orbit, particularly looking at the horizon, did bring to mind how thin the atmosphere is and how easily it's affected by what we do. I'm much fonder of the Earth now. It's like leaving home. I'm much fonder of it now.
It's people like Piers who, in the 19th century, administered the British Empire.
My condition has a 1% chance of survival. I've got 500 days. I'm going to use them. Until we see you again, float on.
So for all of us, the important point is what Pierre said. We're all in this together, one planet, one climate, one people, one species. We're all Homo sapiens. He wanted all of us to work really hard for the benefit of the planet. This involves many different disciplines collaborating, but it's something which is really important, and Piers was interested in science to his last few hours. I was fortunate to be with him a day and a half before he passed on, and when in between morphine injections for the pain of the cancer which he had pancreatic cancer, he wanted to talk about science, and then he retained his sense of humor. I actually asked him what kind of tree he wanted planted in his honor, because at the Johnson Space Center, there's a grove of trees planted for astronauts who have passed on. And he looked me in the eye and he said, "No tree for me." And then he said, "I want an English shrubbery, not too tall, slightly curved, and not expensive." And that's right out of Monty Python's Of the Life of Brian. And then he said, "Tuckaroo, it's up to you to make sure this happens." Well, I'm sorry to say I tried but didn't succeed. But we all miss Piers. He was an inspiration to anyone who knew him. He would spend time with graduate students, postdocs, undergraduates, anyone who was interested in science. And he was tireless in these ways, and an inspiration to all of us to get out and be good earth scientists and do what we can and have a good time doing it. If he was with us now, he would be having a beer. So thank you.